Welcome back to my YouTube channel Grandpa Mathematics. Today we'll be doing some more problems on variables and separables. The volume of a spherical balloon being inflated changes at a constant rate. If initially its radius is 3 units and after 3 seconds it is 6 units, find the radius of the balloon after t seconds. First you have to see volume of a spherical balloon being inflated changes at a constant rate. So let V, R be the volume and radius of the spherical balloon at any instant t. Volume changes at a constant rate. B is the volume. V changes at a constant rate. Rate means with respect to time. So dV, this gives dV by dt is equal to constant. Volume changes at a constant rate. Rate means with respect to time. So dV by dt is equal to K. K is constant. What are the conditions given? Initially its radius is 3 units. Initially means what? At time t is equal to 0. At t is equal to 0, r is equal to 3 units. And after 3 seconds, it is 6 units. That is at t is equal to 3 seconds, r is equal to 6 units. Here, when volume changes, the radius also changes. So that means we should get some relation between volume and the radius of the spherical balloon. So we know that volume of the spherical balloon, that is volume of the sphere, is 4 by 3 pi r cube. Volume is 4 by 3 pi r cube. dV by dt is constant. So we will differentiate with respect to time. So this gives dV by dt is equal to 4 by 3 pi r cube, if we differentiate 3r square into dr by dt. We know that dV by dt is constant k. So this gives k by 4 pi is equal to r square dr by dt. K is constant, 4 pi is constant. We will replace k by 4 pi with capital K. So we can say that r square dr by dt is equal to k. Small k by 4 pi we are taking as k. Because k is constant, k by 4 pi is constant, so we have replaced this constant by capital K. Now this is the differential equation and these are the conditions. So we have to integrate this and apply this condition. We can rewrite that the r square dr, that is equal to k times dt. On integrating we get integral r square dr is equal to integral k dt. This one if we integrate r cube by 3 is equal to k t plus constant. Here two constants, k is a constant, c is also constant. We have to find the value of these two constants by using these two initial conditions. At t is 0 or t seconds, r is 3 units. So put t is equal to 0 and r is equal to 3 in this equation 1 we get. R is 3 cube by 3 is equal to t is 0 plus c. So 3 square. So c is equal to 9. Therefore equation 1 becomes r cube by 3 is equal to k t plus 9. We call this equation 2. The second condition is at t is equal to 3 seconds, r is equal to 6 units. So in this equation, put t is equal to 3 and r is equal to 6, we will be getting the value of capital K. So substitute t is 3, r is 6 in equation 2, r is 6. So 6 into 6 square by 3, k t is 3 plus 9. K value is 21. Therefore, equation 2 becomes r cube by 3, k is 21. 21t plus 9. Now actually what we want, find the radius of the balloon after t seconds. That means r is equal to what when t is equal to t seconds. So we'll rewrite this. R cube is equal to 21 into 3, 63t plus 27. This gives r values 63t plus 27 power 1 by 3 units. So this is the answer. So in this problem, principal increases continuously at the rate of r% per year. We have to find the value of r if rupees 100 double itself in 10 years. So we can say let P be the principal at any instant t. Then principal increases continuously at the rate of r% per year. Here rate means with respect to time. So P increases, P changes with respect to time at the rate of r% per year. So that means dp by dt. So this is equal to P increases at the rate of r% per year, r% of P, r% of P per year. So this we can write as r% means r by 100 P. So dp by dt is r by 100 P. So this is the differential equation. Now we have to see the condition. Rupees 100 double itself in 10 years. That means at time t is equal to 0, principal is 100 rupees. That is at t is equal to 0 years, p is equal to 100 rupees. At t is equal to 10, p becomes 200. So these two are the conditions. So this is the differential equation. So from this statement, we are writing these two conditions. So we'll rewrite the equation 1. dp by p, this is equal to r by 100 dt. We are taking p one side and t the other side. On integrating, we get in the dp by p is log p. So this is equal to r by 100 is constant, integral dt is t plus constant. Here there are two unknowns. C is a constant which we have to find, r percent. The value of r also we have to find, and we are given two conditions are given. At t is equal to 0, put t is equal to 0 and p is equal to 100, we get p is 100, log 100 is t is 0 means 0 plus c, this gives c is log 100. Therefore equation 1 becomes log p is equal to r by 100 t plus c is log 100. Now put t is 10 and p is 200. P is 200. Is equal to r by 100. T is 10 plus log 100. So from this equation we have to find the value of r. So we will say r by 10 is equal to log 200 minus log 100. This is in the form of log m minus log n. That is nothing but log m by n, log 200 by 100. Log m minus log n is log m by n. So this is nothing but log 2. So therefore r value is 10 times log 2. Log 2 value is given 0.6931. So is equal to 10 times 0.6931 is equal to 6.931. Therefore the value of r is 6.931% per year. So this is the answer. In a bank, principal increases continuously at the rate of 5% per year. An amount of rupees 1000 is deposited with this bank. How much will it worth after 10 years? So let us take, let P be the principal at any time T. So P increases continuously at the rate of 5% per year. So P changes with respect to time. P increases means P changes at the rate of 5% per year. P changes with the time. So dP by dt is equal to 5% per year. 5% of P per year. So this is nothing but 5 by 100 P. So this is the differential equation, and 1000 is deposited with this bank. That means that T is equal to 0, P is equal to 1000 rupees. So I am writing all these things, but while doing the problem, one need not write this statement. So that means amount of rupees 1000 deposited with this bank means at T is equal to 0, P is equal to 1000. How much will it worth? That means P is how much after 10 years when T is equal to 10, P is how much? So this is the differential equation and this is the condition, and we have to find the value of P after by putting T is 10. So we can rewrite this as dP by P is equal to 1 by 20 times dt. On integrating, we get we'll get log P is equal to 1 by 20 times T plus constant. So when put T is equal to 0 and P is equal to 1000, we get therefore equation 1 becomes now we have to find the value of P when T is equal to 10. So P is how much? T is equal to 10. Log P minus log 1000 is equal to 1 by 20 into T is 10. Log M minus log N is log M by N. So log of P by 1000, this is equal to 1 by 2. We have to find the value of P. For that we have to rewrite this as e power log of P by 1000. This equal to e power 0.5. We know that e power log x is equal to x only. So e power log P by 1000, that is nothing but P by 1000 only, and e power 0.5, this value is 1.648. So this gives the value of P is equal to rupees 1648. In a culture, the bacteria count is 1 lakh. The number is increased by 10% in 2 hours. In how many hours will the count reach 2 lakh? If the rate of growth of bacteria is proportional to the number present, let G be the number of bacteria at any time t. So what is given? The rate of growth of bacteria is proportional to the number present. Rate of growth, G is the bacteria at any time t. Rate means with respect to time. So dg by dt, this is the rate of growth of the bacteria. G is the number of bacteria at any instant t. dg by dt is t is time. Rate means always with respect to time only. So dg by dt is nothing but the rate of growth of bacteria at any instant. This is proportional to the number present at that time. That is proportional to G. So the proportionality, we can replace this with constant. So dg by dt, this is equal to k times g. K is a constant. So we can rewrite this as dg by g is equal to k into dt. On integrating we get log g is equal to k times t plus constant. So G is the number of bacteria at any instant t. So we have to find the values of C and K. Both unknowns are there. In a culture, the bacteria count is 1 lakh. That is at t is equal to 0, G is equal to 1 lakh. In a culture, the bacteria count is 1 lakh means at t is equal to 0, G is 1 lakh. The number increased by 10% in 2 hours. So at t is equal to 2 hours, G is how much? Increased by 10%. 10% of this is 10,000. So it will be 1,10,000. So these are the two conditions given to evaluate these two constants. So put t is equal to 0 and G is 1 lakh in equation 1, we get log 1 lakh. This is equal to k times t is 0. So it will become 0, t is 0 plus c. That means c is equal to log of 1 lakh. Therefore, the equation 1 becomes log g is equal to k times t plus log 1 lakh. We call this equation 2. So put t is equal to 2 and G is 1,10,000 in this equation 2. We will get the value of k. So we'll find the value for k from here. So log of 1,10,000 minus log of 1 lakh. So this is equal to 2k. So log m minus log n is log m by n. So log by 1 lakh, this is equal to 2k, or 2k is equal to log of 11 by 10, or k is equal to 1 by 2 times log of 11 by 10. Log g is equal to k is 1 by 2 times log of 11 by 10 t plus log 1 lakh. So log g is equal to 1 by 2 times k. For k we are substituting this value t plus constant. Now, in how many hours will the count reach 2 lakh? That means t is how much when g is equal to 2 lakhs. So put g is 2 lakh here and get the value of t. Log m minus log n is log m by n. So log of 2 lakh by 1 lakh is equal to 1 by 2 times log of 11 by 10 t. So this will become simply log 2. Therefore t is equal to log 2, this 2 will go to numerator and that will come to the denominator. So this many hours. The general solution of the differential equation we have to see. So we'll rewrite this as dy by dx e power x into e power y. So we'll take dy is the numerator, so we can have e power minus y dy is equal to e power x dx. Then integrating will get, this will be e power minus y by minus 1 is equal to e power x plus constant. So e power minus y is equal to minus e power x minus c. So when you bring this to the left hand side, e power x plus e power minus y is equal to, you can say, some constant. So e power x plus e power minus y is constant. So this is the answer. Thank you for watching.